Welcome back. This is the second lesson recording for IM2, January 25th, 2021. So I hope by now you can confidently go from standard form of quadratic equation to factored form and vice versa. Okay, you do that by factoring or using distributive property, which is basically FOIL, or FOIL is a distributive property. So you can go back and forth, and that's going to be helping you in being able to graph accurately and easily. Alright, so one of the things that we do use when we are graphing is zero product property. So I want you to pause the video and take notes here. If A multiplied by B is equal to 0, then either A is equal to 0 or B is equal to 0 or both. So, or when the product, the result of multiplication of two or more factors is 0, at least one of the factors must be equal to 0. So we use that fact to find the x-intercept, because we know that calculating the x-intercept in factored form, we know that to find the x-intercept, we know that the x or the y-coordinate of x-intercept is always going to be 0. Okay, so then we use that fact and we set y to be 0. So the equation becomes x minus 1 multiplied by x minus 3 is set to be equal to 0, because that's what's true for all x-intercept. The y value is 0. Then from here you break it into two different branches. X minus 1 must be 0, or x minus 3 is equal to 0. This is the zero product property. Okay, if two things multiplied to each other is 0, that means at the very least the first thing is equal to 0, or the second thing is equal to 0, or possibly both. Then from here you solve, get rid of the parentheses, and you get x is equal to 1. Get rid of the parentheses and add 3 to both sides, and you get x is equal to 3. So you have just figured out that the first point is 1, 0 and 3, 0 for the second x-intercept. Alright, so then we went on to say, okay, what are the x-intercepts? Identify the x-intercepts in both. Okay, so then please pause the video and see if you can identify yourself. Again, you look at the factors, two factors, the expression inside the first parenthesis, you set that to be equal to 0, because we know that y is going to be equal to 0 for x-intercept, or 4x plus 1 is equal to 0. And then from there you solve and you get your first x-intercept to be 2, 0, or negative 1/4, 0. For the second problem, you do the same thing. You first set 2x minus 5 is equal to 0, or 10x plus 1 is equal to 0. And then you solve each of the branches separately, and you do get x is equal to 5 over 2, or 2.5, or x is equal to negative 1/10, or 0.1. This is a typo. This should really say negative 0.1. Okay, but what about the multiplier in the front? Okay, so if you have y is equal to 2x minus 5 multiplied by 10x plus 1, what if there is a 2 in front, or negative 2 for that matter, or 0.5? The factors are exactly the same, but there is some number being multiplied. Those are called the multiplier. How does the multiplier change the graph? Okay, let's graph the four equations on Desmos and see. To do that, you're going to go to desmos.com/calculator. You're basically calling the Desmos graphing calculator, and then you are going to type in y is equal to parenthesis 2x minus 5 multiplied by 10x plus 1. And the graphing calculator or Desmos will graph it for you. This is what it will look like. Now, what if everything else is the same, but there is this multiplier of 2? What would that look like? Okay, look what happened to the original equation. The x-intercept stayed the same. However, the parabola got stretched. It's almost as if you pulled from top end and the bottom end and stretched apart, and it became more skinny. Okay, what if instead of positive 2, let's compare these two. What if it was positive 2 versus negative 2? Okay, this is positive and this is negative. Okay, what happens with the negative? It's the x-intercept is the same. the shapes are exactly the same, but it is flipped, or it's opening downwards. Okay, in contrast, what about if the number in front is like 0.5? How does that look different? Again, this is just when multiplied by 2, and this is when multiplied by 0.5. It's as if the parabola is more open, it's squashed down. Okay, so, or we say that it's compressed. So hopefully you have discovered that the role of the multiplier, and sometimes called scale factor, is that it expands, that creates a skinny parabola, or compresses, that creates a flat parabola of the parabola. Okay, if the number is negative, then if the multiplier is negative, then parabola opens downwards, and if the multiplier is positive, the parabola will open upwards. So it basically flips the parabola open to down if you have a negative number in front, if the multiplier is negative. Okay, all right, then what about y-intercept? We figured out how to quickly find the y-intercept when it is in the standard form from last lesson by looking at the constant. Okay, how about if it is in factored form? What do we do to find the y-intercept? Well, y-intercept, what do we know about y-intercept? The x-coordinate is always going to be 0, regardless of what the coordinate is, what the point is. So we're going to use that fact. The x-coordinate of the y-intercept is always 0, so you're going to substitute x to be equal to 0 into the factored form of the equation you have. And so wherever you see an x, you're going to put 0, so it becomes 0 minus 1 in parentheses and 0 minus 3 in parentheses. So that just simplifies to negative 1 multiplied by negative 3, which is positive 3. So now I know that the y-intercept of this graph is 0, 3. Okay, so y-intercepts are generally pretty easy to find, and it is a great point to make sure that your graphing is correct. Okay, after you've done the vertex, after you've done the x-intercept, then finding the y-intercept will help you make sure that you are not making any silly mistakes. Okay, now the question comes to how many points? How many points do I need to be able to sketch a decent parabola? That means I want to be able to get an idea of, where the parabola should be, where it's located, what are the basic shape, and so on and so forth. Okay, so to do that, we are going to be looking to see, okay, if you just have one y-intercept at 0, negative 7, can you create a parabola that is unique? Why or why not? Well, the parabola could have the y-intercept of 0, negative 7 right here. It could look like this, but it could also look like this. It could be opening up or down. It could also be shifted to the right of the center, or it could also be shifted to the right but opening down. Okay, so there are many variabilities. Just because you have the y-intercept of 0, negative 7 does not mean that you can graph that parabola. Okay, so that's not enough information. What about if you have 2 x-intercept? Is that enough information for us to be able to sketch a parabola? Well, this could be what the parabola looks like with x-intercept of negative 3, 50. Or it could look like this. It could be opening up or it could be opening down. They all have the same x-intercept. So x-intercept is not enough. On top of that, you can create a skinny parabola or fat parabola depending on the multiplier, as we have figured out. Okay, so again, x-intercepts alone are not sufficient to be able to create a unique or accurate graph. So what do we need? Okay, what if we have 2 x-intercepts and a y-intercept? Well, if that is true, then if we know that it goes through this y-intercept, well, that is true that it does create a unique parabola. However, we don't know exactly where the vertex is. Okay, so we don't know what this point is. Is there a way for us to find the vertex? Now, what if we have 2 x-intercepts and the vertex? This time we're given the x-intercepts and the vertex, and let's try graphing it. So with the two x-intercepts and the vertex, we can do a pretty darn good graph, okay? Because we can use the symmetry of the parabola, because it's always symmetrical. We know the lowest point and the x-intercept. So that comes to a question of how do we get the vertex from the equation easily? Well, what do we know about vertex? We know that if you have a two x-intercept, if you've identified the x-intercept as 1, 0 and 3, 0, we know that that is the lowest point, is the vertex, and we know that it is also going through the line of symmetry, okay? Because we know that it's always symmetrical, it's the lowest point, vertex always goes through the line of symmetry. And using that fact, that means the distance from the line of symmetry, this distance has to be equal to this distance. So we can find the x-coordinate of the vertex by taking the average of the x-intercepts. So x-coordinate is going to be, x-intercept is going to be 1 and 3. So you add those two together. Taking the average means add the two numbers and then divide by however many numbers that you are dealing with. So it's going to, we added two numbers, so you're going to take divided by 2. So 3 plus 1 is 4, divided by 2 is equal to 2. So we know that this x-coordinate of this vertex is 2. How do we get the y-coordinate? Well, we have this equation, that's the equation of this line, or this parabola. So we substitute the x-coordinate, x is equal to 2, into the equation. When we do that, y is equal to, becomes 2 minus 1. Wherever you see an x here, you substitute 2. 2 minus 1 multiplied by 2 minus 3. 2 minus 3. So you get 1 multiplied by negative 1, which is negative 1. So I have just figured out the vertex coordinate is 2, is my x-coordinate, and the y-coordinate is negative 1. Okay, so what about if you were in standard form? I am just quickly going to mention this as a notable mention because I do see some of the students using it. If it's in standard form, you can certainly use this formula x is equals to negative b over 2a, where standard form refers to when equation is in the ax squared plus bx plus c. So the number in front of x squared term is the a value, b is the number in front of the x term, and c is the constant value. So you plug that in. Okay, so a is 1, b is negative 4, c is 3. You plug that in into this formula here, and notice that there is a negative 4 that becomes positive 4 divided by 2, which is 2, which is what we had before. And then from here, you do the same thing as previous way. To find the y-coordinate, you substitute it into the x, and you find the y value to be negative 1. And so the vertex is 2, negative 1, which is exactly what we found. Okay, so graphing quadratic equation. So you're going to take notes here. If you have a standard form, then you need to first convert it to factored form by factoring. Then you identify the x-intercepts, and then you calculate the vertex of the coordinates of the vertex, and where you are finding the average of the two x-intercepts, and that's going to be the x value of the vertex, and the y value is you plug in the x value you just found into the equation to find what the y value is. And then you also identify the y-intercept. This is the bonus that will help you make sure that all your calculations and your graphing is correct so far, and then you make the sketch. So these are the steps involved. So please pause the video and copy this down. And I am going to go over this in next video, and we're going to solve this problem, and we're going to sketch it.